All right, now this is the video I did just a few days ago, and it's on this TNF, tumor necrosis factor. And there's a spot in here that shows this woman. Well, here it is right here. I'm going to play this because it's instantaneous, absolutely instantaneous. You should come up and watch this. It's 14 minutes long, but here goes.
For a stroke patient, which makes the work of one clinic in America so tantalizing. Its results have to be seen to be believed. The therapy is controversial and heavily criticised, but the patients say it's truly miraculous.
Can you please count from 1 to 10?
Every minute of Linda Lumbra's daily life is a frustrating struggle. She suffered a stroke 3 years ago, which left this teacher barely able to walk or talk.
4, 5.
Doctors have told her this is how she'll be forever. That's why Linda's travelled to this Florida clinic to try a controversial new stroke treatment.
Well, I can understand why you would. The speech makes it very frustrating.
It's her last shot. One injection of a drug called etanercept into her spinal cord at the back of the neck.
What's different?
Brief few minutes pass to let the drug flow to her brain.
Clear. Okay.
And not even Linda or the doctors here expect what happens next.
Okay, did it look cloudy? Okay, now it's clear.
Oh my.
It was a bullseye hit on the pathology that was interfering with her brain function.
Yeah, you're doing fine. You're doing.
She is a firecracker, man. This is just heartwarming to see this. And just think of, and nobody would help her. Nobody would allow this. And now she's just absolutely flawless. Right here she is when she's getting up out of the chair here.
It worked.
This is 5 minutes later.
Yeah.
Just 5 minutes later, and they are fighting this.
Here is clear. Hi, it's me. It's truly a miracle. It happens all so quickly, and it's done.
And it's done, and you don't have to go back. You don't have to go back. It's done. Whatever these tumor necrosis factor molecules that are so big they cannot get out of your brain, they are neutralized. Now, I don't know, if you got another damage, I don't know. I have no clue about after this. But it appears, and I understand the catalysts, and I understand molecules, and I understand the way they bond and attach, it's instantaneous. Everybody thinks, oh, it takes a time and it sort of migrates. No, done. And that's exactly what happened to them. And she is now a firecracker. Before, she could not get her finger back to her face or to her nose. And she's just having a great time. All right, before you can even start to understand anything, you have to understand what happens when you have an injury. That injury is being attacked by tumor necrosis factor, and that causes inflammation. Here's the story with tumor necrosis factor. Now, tumor is, you know what a tumor is. It's something that grows cells, or there's irregular cells, or there's injury. Then you also have necrosis, means death. And then the factor is this particular type of stuff. And these Kaysen or Kisten, once named as tumor necrosis factor alpha, or TNFA, is a cell signaling protein cytokine. You're going to hear this a lot. This cytokine is involved in this TNF, and it's the inflamer. It is involved in systemic inflammation and is one of the cytokines that make up the acute phase reaction. What is the acute phase reaction? That is what they call the flare-up. in rheumatoid arthritis. So these tumor necrosis factors come in and bam, they smack the hell out of the receptors in your joints, not because they're attacking your joints because there's no problem. They're attacking your joints because the membranes in your joints are wearing through. And why are they wearing through? Either the bacteria that's supposed to be in there that creates the synovial sheath sliding slurpees in there, the mucus and all the slimy stuff, because it's in every one of these membranes there's bound bacteria. That's my understanding. It's memory bound bacteria, and that protects the bloody side of stuff, where your cells are and all that stuff, from the areas that are what they call extracellular. All right, they're not supposed to be within the matrix. That's why you have a membrane. Stay out that side, you stay in this side. And what happens is you break through the membrane. Then, and what happens is a lot of times in rheumatoid arthritis, it's all in joints. Why is it in the joints? Well, they have to slide over here. You got tendons sliding back and forth, back and forth, back and forth, rubbing this way, rubbing that way. The bones have to go against each other, up and down, sideways, this way and that way. Well, that's a lot of squishing and scrubbing. Now, what if you had some silicon crystals in there, or you had some aluminum crystals in there, or you had some form of salts that collected in these joints and were not being removed? Or you had some acids that were in there that were attacking the membrane, and the products that are supposed to be delivered down there to neutralize that reaction can't get there because you don't have the bacteria in your gut to collect the metals and so forth to deliver these products. So, I work with people who have arthritis. I'm just a busybody. I like to know things, and I like to find out things. I like to try to see if I can figure out what's going on. And I found a castor oil on any slurpy area, any area that's sliding with synovial sheathing and so forth. This particular molecule I can go through the chemistry. It's 18 carbons in the chain. On the 12th carbon is a hydroxyl group. That is a very reactive OH molecule. It wants to react and break other molecules and reassociate and deassociate and change magnetism, basically. It's polarity. It's not necessarily polarity, but acidity. That's how your things are exchanged in your body. One of them says, I need a negative particle, and I want a positive particle. So, okay, we can work together. Bada bing. And it's instantaneous. Now, this is the TNF molecule. That sucker is gigantic, and in my world, it never goes bad. You cannot destroy it. That's why they find it in the urine and the feces, because it's got to get out of there through some process that eliminates it. Your kidney, well, you use both kidneys and feces. I mean, that's what it is. Now, it's in both places coming out. So, when it's in your brain, that sucker there is too big. You got a spot that's this big around coming out of your brain. And say, I can't go through there. So, well, just stay up in there. I said, well, every time the guy hits me in the head, every time I bang my head, I'm going to have some more of these. Well, nothing I can do about it. You can't get through. So it stays in your brain, and before long you start getting cloudy and forgetful, and then that's it. But you can't get that out of your brain. Every time you get hit in the head, you're in trouble. These people are getting concussions, these boxers and fighters and stuff, these ultra fighters or whatever they call them. Holy smokes, man. They're going to be walking around at the telephone poles before long. This is not good. Absolutely not. I fully understand this now. Absolutely fully understand the process that happens in the brain. The receptors are being attached and attacked. They're inflaming because of these things. They're shot right into the fluid in your brain, goes past the blood-brain barrier, and now that's the only way you can get it in there. Otherwise, you could just shoot it in your arm, you'd be all set, but it can't. So you put right in the brain, and it just does whatever it does to these. It deactivates them or breaks them down or attaches to them, but it's instantaneous. Literally instantaneous. This is another one they're trying to destroy. They got a person in jail right now over in France, and they took everything these people own for this GC math. And guess what? He claims it kills tumors. And guess what it says here? tumoricidal activity of GC-MAF-treated macrophages was detected. What's the deal? The only thing they didn't find was TNF and nitrous oxide. So what? Tumoricidal activity detected. And this guy's got one of his assistants is in jail. This is 15 years ago they knew this. I don't know what's going on. I have no idea who is in charge anymore. The inmates are running the asylum. All right, I'm going to make this as clear as I possibly can, and it can't be any clearer than this. Your brain can take a little injury, but it cannot take a massive injury. Your brain can take a little injury now and then, but in rapid succession, the little injuries are just as bad as the big injuries. And how can I say this? Well, here's how I can say it. This TNF-alpha is tumor necrosis factor alpha, and they measured it, and I've looked into this very, very closely, and here's what happens. Trauma victims suffer repeated hemorrhages sometimes, but the response of cytokines to it have not been described. The cytokines are associated as TNF factor activity. Now, so to study this question, we first detected the time course of changes in serum tumor necrosis factor TNF activity. So how much is in there, and how long does it last, and all that kind of stuff. So here's the bottom line. I don't want to go through all this milliliters and kilograms and all that business. Here's what it ends up being shown. TNF activity showed no significant increase after either size of hemorrhage. In other words, a small one and a little bit bigger one. But the mRNA level, both 15 and 20 hemorrhage, induced significant increase after hemorrhage. So in other words, the bigger ones, you got a significant increase in the TNF factor, whereas the smaller one, the 10, did not. However, when the 10 hemorrhage was repeated again within 24 hours, the TNF-alpha factor increased significantly. So this TNF factor is the thing that sets off inflammation and all of the factors that cause issues with your brain. And it cannot get out of the brain because the blood-brain barrier is too tight to let it out. And this stuff never goes away. So they can find this TNF alpha in urine and feces. And that's what this doctor did in 1977, and they just shut it down. They wouldn't allow it. And now today, it's a big deal. Oh boy, now we just found this stuff. All right, so don't forget now, this is 1998, so that's 20 years ago right there. All right, this goes into this tumor necrosis factor again in anti-neoplastons. First, as possible cancer treatment in 1976. They were originally isolated from human urine and feces. And it's because you're passing these tumor necrosis factor molecules. They don't seem to degrade. That's why when they get stuck in your brain, they stay there forever. They don't seem to degrade. You pass them out of your body, and this guy was collecting them up out of feces and urine. And then they just destroyed them. It was first proposed in 76, originally isolated from human urine, now synthesized from chemicals in a developer's laboratory, which is this guy in 1976. It's not approved for any treatment, for prevention or treatment of any disease. Well, let me see, the U.S. Food and Drug Administration is the administration for the prevention of treatment of any disease. Wow, I didn't even know that. No randomized control trials showing effectiveness have been published in peer-reviewed scientific literature because they won't look at it, I guarantee you. Antiplaston side effects can include serious neurological... Well, who knows? How do they know that if they won't look at it and there's no peer review on it? Non-randomized clinical trials investigating anti-cancer efficacy antiplastons are underway at the Developers Institute, and they prove to be all positive and discarded. This is one of the worst tragedies I've seen. Unbelievable. This guy is over, he has, I think it's his wife or his assistant or somebody, is in prison over in France because they want to make this GC-MAF. So they say, oh, well, you can't make it because we're not going to let you. We're going to put you in prison. And apparently they say because it doesn't work. But guess what? This is the tumoricidal activity. That means it's killing the tumors, which he says it's supposed to do, of this GC-MAF treated macrophage was detected. It was detected. It's there. It's doing its job. But no release of TNF and nitrous oxide was detected. So what? It's killing the tumor. That's what the guy said. What does he have to say? Oh, it's here. This molecule attacks that molecule. Well, if it works, it works. They're saying it works. This is PubMed. This is no morons. This is U.S. National Library of Medicine, National Institute of Health. They say it works. Why is this person in jail? No, I primarily look at the TNF, but it doesn't matter. It is curing. Or they don't even accept TNF. So what, they don't accept anything. Nothing. It's the most disgraceful people I've ever seen.
And David was here at Southern Crown Court to respond to the court's attempt to fleece him of everything that he might still believe that he has as possession. So David, unfortunately I didn't make it in time because it took me 2 hours to get up from South Wales and then an hour to get across London. So unfortunately I literally arrived in the court and was coming out the lift as you guys were getting in. So can you give us an update on what transpired in the court this morning?
Well, I told the court that Linda Thayer, an innocent woman who is in a French jail put there by the MHRA, is still on hunger strike after 2 months and has now attempted suicide twice, and she almost certainly will not see the new year in. The MHRA will almost certainly kill her by Christmas. But that's no problem for them. They kill 200,000 people a year, so what does one more matter? So they wanted me to fill out a form of everything I possess. We've already done that verbally with my solicitor. But having nearly 5 years ago taken all my bank accounts away, they want to make absolutely certain that I have nothing left. Because, of course, if I have nothing, I can't make GC-MAF anymore, which is the exercise. The entire exercise is aimed at preventing GC-MAF from ever hitting the public.
All right. This guy is in the worst possible position any human could find himself in. He's doing something good, trying to benefit humanity, and they are destroying him, and they have destroyed him, and they will kill this person in the jail. They're in jail. I just can't believe the world that we have inherited. Absolutely can't believe it. And I'm not going to do this video over. I don't care who says what about it. It's a disgusting medical society now. Disgusting. All right, so that's my claim. You will not feel happy when you find out what has happened here. Now, the first place these things started showing up were in feces and urine as waste peptides. They are being purged out of your body because they're in there to help you. So they looked into this, and of course the FDA and all these people, in their wisdom, said, although several possible mechanisms of action, theories about the activity of these anti-neoplastons have been proposed, specifically are for this particular A10. None of the theories has been conclusively demonstrated. And then they go on to conduct clinical drug trials. You're going to have to do all this, and the application can be only disclosed by only any, and they go on and make it so impossible. This is 1977. All right, you with me? 1977. This guy, Brzezinski, was doing this research, and it was good research. All right, I'm going to try to make this as coherent as possible. This goes back to July of 1987, and they're talking about recombinant human tumor necrosis factor alpha stimulates production of this granulocyte colony stimulating factor. Well, granulocyte colony, they produce stem cells, so you want that. So this recombinant, I don't know how they recombine it, but it's from this TNF alpha necrosis factor. Now, So it comes down here, it says tumor necrosis factor alpha stimulates production of this type of colony, this GCF and protein and mitochondrial RNA in fibroblast cells. In contrast, TNF beta, which is, we're talking about the TNF alpha first of all. Now we got the TNF beta, is at least 1,000 times less potent than the alpha in increasing levels of this activity in the mRNA. Now, fibroblasts produce this stuff in coordination after exposure to TNF. Fibroblasts are connective tissue fibers. The ability of TNF alpha to stimulate production of CSF in fibroblasts may be pivotal to regulation of hematopoiesis. And guess what that big word means? It means the production of blood cells and platelets which occurs in the bone marrow. And that's what I think is the source of these good products that you need in your body to regulate your body. Now, they need to get out of your body too. And when they are produced in it's maybe like in the bone marrow of the brain or somewhere up in that area, somewhere in the cranial area, above where you get bashed in that bone up there, maybe that's where you got an issue, and it starts to create these TNF molecules, and now they can't get out of that brain area. All right, so I think it might be related to bone concussions. I you know, at this point, I'm almost certain it's related to this TNF alpha and not being able to leave. So here's what I'm just going to leave it at this: TNF alpha, it's tumor necrosis alpha. Cytokines are the signaling cells, and that's what they create. The signaling cells go and they say, get inflamed, do all this stuff because you're injured. Come on, make it, do this. And now you got injuries just continuously being, and even when if they could heal, well, they can't heal because they're just continuously being infested by these tumor necrosis factors. They're supposed to come and say, get hot, fix yourself up, I'm leaving. Well, they can't leave. Now, these things have been found in stem cells, and this blood, as I was just telling you, it stimulates the bone marrow to produce these tumor necrosis factor. Now, and you end up finding them in the wastes, in the peptides, okay, in your feces, in your urine. They have these TNF alpha because they're too big to break down in the body. They're tough. They last forever, it appears. Because once you get a major stroke, you can't be fixed, they say. Well, you just saw one shot and she's fixed. You have to speak up. You have to talk to your doctor. It's time that we take control of it. You see all this stuff 30, 40, 50, 60 years ago they were doing this research, and it proved to be exactly correct. And now all of a sudden, oh, we just discovered this last week. But they're going to take a whole new take on it and make it go into some drug that's going to make you sick in some other way and then help you in some other way. I have no clue. But I'm going to tell you right now, I see very little to brag about. As my grandmother used to say, I don't see anything to write home about medicine. You know, here's another tidbit to, you know, support what I'm saying. She says, I work with stem cells, and here's why I won't be injecting them into myself. Well, let's just go down to the important part. She's saying that it's not a new therapy. Unrelentingly, it is far from a new concept. Bone marrow. This is the key. Bone marrow transplants successfully used to treat leukemia patients for decades. Why? Why bone marrow? Because it has stem cells. Why stem cells? Because they have that TNF factor. And then it comes out of your body. But once, if you shoot it into your brain, it may help, and it may actually cure you. I can't be certain, but you know, there's going to be a certain number of this TNF factor that's going to be allowed up there, and then if you go past that amount, I think you're in trouble. And people, I'm sure I have TNF in my brain. Everybody gets banged in their brain every now and then. And if that's what happens, and it's too big of a molecule to get out and last forever, it is in your brain. If you get a lot of it, you're in trouble. But if you have some form of a disability now, as you age, that is dementia and this aplasia. Well, here, hold on a second. All right, this primary progressive aphasia. As you get older, this just happens. There must be something breaking down in your brain that says, okay, let's go fix this up a little bit. We can fix that up. We can fix that up. And so, what do we want to do with all the scraps? Well, that TNF stuff, I don't know. Just throw it on the side. Sooner or later, it starts attaching and inflaming your brain. Then you just get lost, and that's what happens. Happened to people I know, many of them. And it's probably going to happen to me too, maybe tomorrow. I don't know. But it's time to take this into our own hands. This is crazy to let this go on. So years and years and years and years and years that I don't know what they do, but they make it illegal for you to do anything unless they say it's okay. That's not right to me. Something's not right here. Okay, it's tumor necrosis factor A. It's all fallen into place now. The tumor necrosis factor A is one of the parts of the molecule, and that is the coordinator, the director, the targeter. That's the thing that says, okay, we're going to go start inflammation over here because we got an issue. And it brings along with it the other part, which is the tumor necrosis B, which is granulocytes, I think they call them. And what that does, that's the part that heals you. Now, the TNF factor A is supposed to leave and get purged out of your body, and they do find it in the urine primarily. But it's a molecule that cannot get out of your body. It appears to be that originally they thought it was only produced in one place, but now they find it's produced basically almost anywhere in your body. And it appears that when this is produced in your brain because of whatever the invasion and effect on your brain is, that makes it create some kind of a lesion or an injury or a little blood damage or whatever it is. And then the TNFA comes along and says, come on, guys, let's go over there and fix that up. And then it says, okay, I'm all done. I'm going to get out of here. And this is where you're going to go. And it says, can't get out. Can't get out. The blood-brain barrier is too small. So now that's stuck in there. And they just appear. They just don't. They take them out of urine. So nothing is breaking them down. And I don't think they ever break down, because if you get a stroke, you're like that for the rest of your life. Autism, all those kind of things, dementia, once it comes, you're done. So the boxers, the football players, ALS, I think all of that could be affected by this. I'm almost sure of it now. It seems to have that effect on every single one of these issues with the brain, because this tumor necrosis factor A cannot leave, and it is an antagonist, and it continues to inflame the brain, and then you have all kinds of issues until you're so foggy you're done. That's my last word.